Bohdi Park, NEET and G Academy. Your dream, our mission.
Hello everyone, welcome to this session of physics MCQs. Now today's topic is gravitation. So welcome to this Bohdi Park app. You can download it from the description which is mentioned. And let's start with the first question. So this question is based on gravitation. So first question is, the radius of a planet is 1 by 4 times the radius of Earth, and its acceleration due to gravity is 2 times the gravity on Earth. What would be the value of escape velocity on the planet if escape velocity on Earth is VE? So we know that the formula for escape velocity is equal to square root of 2gr. So the escape velocity on Earth by escape velocity on planet is equal to square root of 2 into gr divided by 2 into now gravity on planet and radius of planet. So using this ratio we can find the value of Vp. So VE by Vp, now to 2 cancel, now G by Gp. So Gp is given as 2G and Rp is given as 1 by 4 times radius of Earth. So this 4 will go to the numerators. This is 4 by 2. So this will become square root of 2. So escape velocity on Earth by escape velocity on planet is root 2. So escape velocity on planet is escape velocity on Earth by root 2. Okay. So first option. Now next question. Now look at question number 2. Projectile is fired vertically from Earth. So when something is fired, it is launching. So we are giving some speed, okay, with velocity k times VE, where VE is escape velocity and k is constant, less than unity. Unity means 1. So suppose this is the Earth, this is the center of Earth. Ball is thrown from the surface with velocity k times VE and it will go up, and at the topmost point the velocity becomes 0. So we will conserve the mechanical energy, and finally we have to find the maximum height from the center. So initial distance from the center is capital R, which is the radius of Earth, and final distance from center is small r. So we will use mechanical energy conservation. So K initial or kinetic energy initial plus potential energy initial is equal to K kinetic energy final plus potential energy final. So substitute the values. So we get half mk square VE square minus, what is the formula for potential energy? Gravitational potential energy is minus G m1 m2 by r. So minus G capital M small m by r, and final kinetic energy is 0, and final potential energy is minus G m by small r. So this small m is cancelled on both sides. So k square by 2 into VE square. So we'll put the value of VE. So formula for VE is equal to square root of 2g capital M by capital R. Escape velocity on Earth's surface. So square of that will be 2g m by r minus gm by r is equal to minus gm by small r. So this gm cancel. So 2 also cancelled. So k square by r minus 1 by r is equal to minus 1 by small r. So we have k square minus 1 by capital R is equal to minus 1 by small r, or small r is equal to capital R by 1 minus K square. So C option. Next question. Now look at question number 3. Satellite of mass m orbiting around the earth in a circular orbit with velocity v. What is the total energy? Total energy means total mechanical energy. So it is the sum of kinetic energy and potential energy. Total mechanical energy is equal to kinetic energy plus potential energy. Now we have been given the speed or the velocity v. So we have to find the answer in terms of mass and velocity. So basically kinetic energy, we know it is half m v square, and potential energy, what is the relation between potential energy and kinetic energy? So we have some short tricks over here. Kinetic energy is equal to minus of total energy, and 2 times of total energy is equal to potential energy. So we have total energy is equal to potential energy by 2. So kinetic energy is equal to minus of potential energy by 2, or potential energy is equal to minus 2 times of kinetic energy. So potential energy is equal to minus 2 times of kinetic energy, which is half m v square. So this will become minus 1 minus 2 into half mv square. So minus 1 by 2 into mv square. So D option. And we can also use total energy formula. Total energy is equal to minus of kinetic energy. So directly also we can find minus half into mv square. Next question. Now look at this fourth question. Body is projected up with velocity equal to 3/4 of escape velocity from the surface of Earth. So the speed with which it is thrown is 3 by 4 times escape velocity. The height it reaches from the center of Earth. How to solve? Again, it is the same formula, that is conservation of mechanical energy. So it is thrown with velocity 3 by 4 times escape velocity. It will go up. At the topmost point, the velocity becomes 0. So initial distance from center is capital R, and final distance from center is small r. So we will conserve the mechanical energy, and we have to find the height from the center, that means small r. So initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy. So half m into 3 by 4 VE whole square, and then initial potential energy is minus gmm by r, and final kinetic energy is 0, final potential energy is minus gmm by small r. So this is m is cancelled. So we have 1 by 2 into 9 by 16 into VE square minus g, m is cancelled, gm by r is equal to minus g capital M by small r. So now substitute the value of VE square, which is 2gm by r, then minus gm by r is equal to minus gm by small r. So this gm cancel. So we get 9 by 16 r minus 1 by r is equal to minus 1 by small r, or minus 7 by 16 r is equal to minus 1 by r, or small r minus minus cancel, small r is equal to 16 r by 7, distance from sender. So B option. Next question. Next question talks about planetary motion around sun. Planet is revolving around sun. So this is the elliptical orbit at this point sun, and this planet is moving A to B, B to C, C to D, D to A. This is the elliptical orbit around sun. Which of the following is correct option? The time taken in traveling DAB is less than that for BCD. So basically we have to relate time taken. So we know that the time depends on area. So that is the Kepler's law. Okay. Kepler's second law tells us area by time is constant, or dA by dt is constant. Area swept by position vector. Area swept by position vector is directly proportional to time taken, or it cover equal area in equal interval of time. So if we consider DAB and BCD. So for DAB, here is the sun and this is A, this is B and this is D. So for DAB, this will be the area covered. This area covered for DAB. And for BCD, this is B, this is D, this is C. For BCD, this will be the area covered. Now clearly we can notice over here the area covered from BCD is greater than the area covered from DAB. So area BCD is greater than area DAB. So the time taken from BCD is greater than time taken from DAB. The time taken in traveling DAB is less than time taken from BCD. So first option is correct. Okay. Now the time taken in traveling DAB and BCD, it is showing greater. So DAB is greater, it is showing. So this is wrong. Okay. The time taken CDA is less than that ABC. So for CDA and ABC, the area will be same, so time will be same. So C is also wrong. The time taken in traveling CDA is greater than that of ABC. So clearly it is also wrong. So correct option is A. Now look at this sixth question. We have acceleration due to gravity on planet A is 9 times the acceleration due to gravity on planet B. A man jumps to height 2 meter on surface of A. What is the height jump by same person on planet B? So the thing here, the concept here is when the person jump, the speed will be same. The speed with which the person jump. So suppose the speed is u. So at topmost point velocity is 0. So height covered is h. So we can say 0 square minus u square is equal to 2 into minus g into h. So h is equal to u square by 2g. So h is inversely proportional to g. U will be same for both planet. Same for both planet. So for Earth it is 2 meter. So we can say height on Earth by height on planet is equal to gravity on planet by gravity on Earth. So 2 by HP is equal to, now gravity on planet is 9 times that on planet B. Okay, we have to consider A and B. Okay, fine. So height on A by height on B is equal to gravity on A by gravity on B. So height of person, the height jumped by person on planet A is 2 meter, and height jumped by person on planet B is HB, and gravity on A is 9 times gravity on B. So this ratio will be 9. So we have height jumped on planet B is equal to 2 by 9 meter. So that is B option. Now next question. Next question is 7th question. We have, if suddenly gravitational force of attraction between Earth and satellite becomes 0, then the satellite will. So what will happen to satellite? So we know that, suppose this is the planet or Earth and this is the satellite. So this satellite is revolving around this planet along a circle. So why it is moving circle? It is always turning towards the Earth. It is trying to fall towards the Earth, correct? So if Earth is suddenly vanish, or the force of gravitation suddenly vanish or becomes 0, so the satellite will stop falling towards Earth. So it will move along a straight line. It will move along tangential path or straight line. It will continue to move along the orbit with the same speed? No, it will move tangentially to the original orbit with same speed. So yes, correct. So this is correct. Becomes stationary? No, it will continue moving along a straight line and it will go very far in space. Next question. Now 8th question. We have the potential energy of a satellite having mass small m and rotating at height 6.4 into 10 raised to 6 meter from Earth's surface. So what is the potential energy? So we have a formula of potential energy minus gm small m by r. So we have to find our answer in terms of gravity, that is acceleration due to gravity. So we know that G capital M by R square is equal to small g. So G capital M is equal to G into R square. So that is minus this Gm will be Gr square. So minus G into R square into M by small r. Now the height is given. We know that capital R is equal to 6400 kilometer, and this height is given 6.4 into 10 raised to 6 meter. So this is 6.4 into 10 power 3 kilometer. So 6400 kilometer. So the height is same as radius. So the distance from center is equal to r plus h. So that is r plus r, or we can say 2r. Suppose this is Earth. Now satellite is here. This height and this is the radius of Earth. Both are same. So distance from center is 2r. So we'll substitute here. So minus g is into small capital R square into small m by small r, which is 2r. So this RR cancels, so minus mgr by 2, minus mgr by 2. So C option. Now next question. Now ninth question, we have radius of Earth were to shrink by 1%. With its mass remaining same, the acceleration due to gravity on the Earth's surface would increase or decrease by 1% or 2%. We have to find out. So we know that the formula for acceleration due to gravity is equal to small g is equal to g into capital M by r square. Now mass is remaining same, so g is inversely proportional to radius of Earth square. So we can use the error formula to find the percentage change. Delta g by g is equal to minus 2 times delta r by r. So delta g by g into 100 is equal to minus 2 times delta r by r into 100. So why we are using the error formula? Because the percentage change is very small. So if it is less than 5% or less than 10%, so we can use this formula, error formula, for a small percentage change. So this is the percentage change in gravity, and that is equal to minus 2 times percentage change in radius, which is minus 1%. So it will be plus 2%. So gravity will increase by 2%. D option. Now next question. Now 10th question, we have, suppose the law of gravitation attraction suddenly changes and becomes inverse cube law, i.e. F is inversely proportional to R cube. Then still remaining the central forces. Force is central force. Central force means the force acts along the line joining masses. So we have to find whether area, law of area will hold, or the law of period will hold, or both will hold, or both will not hold. Okay, so let's find out about the time first. So mv square by r, which is centripetal force, and this gravitational force is inversely proportional to r cube. So suppose this is c, some constant c by r cube, rr cancels, so mv square is equal to c by r square. So v is inversely proportional to r. So we have time period is equal to 2 pi r by v, and v is inversely proportional to r. So we can say t is directly proportional to r by v, or t is directly proportional to r by v. V is 1 by r. So t is directly proportional to r square. So clearly the law of period, which is t square proportional to r cube, is not holding. So second option is wrong. So definitely C option is also wrong. Now how to find the area? So you know, suppose this is the circle, and the planet goes from point A to point B. The angle covered is d theta. So the area is equal to d theta by 2 pi into pi r square. So when we calculate dA by dt, it will be equal to d theta by dt into r square by 2. Okay, pi cancel, and d theta by dt is omega. So omega into r square by 2, and r omega is v, so v into r by 2. And we know that angular momentum is equal to mvr, and angular momentum is constant or conserved because the torque is 0. So Vr is constant. So dA by dt is constant. So the law of area holds. A option. So that's it. Thank you.